So guys, as you know, we test the routing part in the last class, and I was going through the different routing protocol code, the different elements of routing that is required to know, understand how routing is done. And also I talked about the different types of routing like static routing, IGP routing, and EGP routing. And I also told you what is the advantage and disadvantage of each one of them. So today I'll show you how static routing is configured, and also I'll show you how OSPF is configured. So first, let me bring up these devices. So let's assume that those users on one side wants to talk with the users on the another region or another location. And intermediately we have a router which will route the traffic. I'll just switch on all these devices. So in the last class we configured the gateway. If you remember, might be it was Friday's class where we configured the gateway. The PC1, PC2 could ping their own gateway. PC4 could ping their own gateway, and the PC3 could ping its own gateway. Now the traffic should go from one gateway to another gateway. Show IP int brief. See, these are the gateways on the router. Let me see if there is any end host. So as of now, there is no end host. But if I take PC4, show IP. Okay, IP for some reason is out. Let me configure it. So what is this? Show run gig 0/1. Okay, so I'll take one of the network from this. Let's say IP 192.168.1.7125525252224 192.168 1.70 is the gateway here. These these users are likely to lose the config once you restart. So better save them first. Okay, once you save them, 192.168 1.70. Yeah, they are reachable to their own gateway. So the PC4 can reach till this point. Definitely, it will not be able to reach the other person because of no routing available. Okay, let me just keep these things bit aside. I keep that console in this way. Okay, so am I able to see the routing table? See, there is a routing table. There is no routing protocol as of now. So what I will do is to talk to the other person. Let me see if these PC have the necessary config. Show IP. No, it also has lost. So what interface it is connected? Show run gig 0/0. So IP 192.168.1.26, 255, 255, 255, 255, 255, 192. The gateway is 168, 1.25, and save this. We can just try to reach that 192, 168.25. So the gateways are reachable. Let me see if I can reach the far end device, which is so and so ping 192.168.1.71. Okay, so you can see that PC1 to PC2, which is .71, it's reachable because the reason is they are all directly connected. If you see show IP route, see this has the network advertised. It knows how to go that side. Similar way, if you open PC3, show IP, what is the gateway here on router 0/2? 192.168.1.98255252525248192.168.7. Save this. Let's see if I can reach the PC. That is ping 192.168.1.71. Okay. So whatever is from the router, when they are directly connected to the from the router, you can see that they are able to ping. Let me also ping. This is done. So let me see what is the IP here. Ping 192.168.1.26. See, that is also reachable. Okay. And if you see the ARP table here, there is the ARP table for all the hosts. So .25 and .26, they are behind this interface of the router. .70 and .71, they are behind this. .97 and .98, they are behind this. If you open the Varsha capture, let's say you want to inspect the packet, how the flow happens. So you can take the capture. Okay. So when you right click this, yeah, over here. Okay. Yeah, packet filters. Not packet filter, sorry, start capture. There was one option, start capture. Okay, 1 second. Okay, I've informed the backend, they will fix it. So once we have the Wireshark capture, we can see how the ping response and the return traffic is sent and received from that particular node. Okay. You can also do a trace route. Let me see if trace is, yeah, trace option is there. See, you did a ping here. You can also do a trace to see in which path this traffic is going. So you see that from PC1, when you did a trace, it went to 1.25. 1.25 is this gateway. From 1.25, router knows how to reach 1.71, which is nothing but this PC. So you can see that there are two hops it is showing. One is 1.25 and then one is 1.71. That is the exiting interface. If you do a trace route of another PC, let's say PC3, show IP 1.98, paste it. See, it came to 1.25, its gateway. Then it checked the routing table. 1.98, it came inside. Okay. If you see this, these are the two hops. Okay, so what I will do is,
Sorry, what, the two hops which is shown, one is its own IP, right?
not its IP, the gateway IP.
Yeah, 25 is gateway on GI0/2.
Yeah. And the
And the second one,
second is the destination IP. The destination IP, the whatever we are trying to ping. So they are directly connected. If there was
okay.
another hop, then that hop will get into picture.
Yeah, if there is another router 2 is connected to router 1, then it will be also shown, right?
Yes.
Okay.
Okay. So
So,
I'll do. Yeah. Tell me.
have we configured the routing table, or it's upon the router that it understand automatically?
It
That
comes automatically. The
okay.
routing table comes automatically. When you put the show IP route table, you will see the routing table built. So we have
Hmm.
not enabled any routing protocol in this scenario.
Okay. Okay.
Okay. Now what I
Once
will
the physical connection is ready, the routing table will be automatically updated, or uh, do, do we need to
no,
try some?
there is nothing to enable. By default, the software has the elements for routing table. So once you bring the interface and the neighborship, etc., happens, the routing table in the backend start getting consolidated.
Oh, okay.
Okay, so these are all auto generated by seeing our IP that we configured on the router. Okay, now what I will do is I will say save project as, maybe I can say 2, and I can say routing protocol. Click on save. Error, why do project must be stopped? Okay, let me stop the project. Save project as 2 routing protocol. Save this. Okay, now what I will do is, instead of these switches, let's remove the switches for now. And let me plug a router itself. So I have a router which is over here. And the same goes over this. I plug a router. Now I'll connect them. So why I did this is, in the earlier case, since we were using the switches, they were getting easily communicated. So now let's keep them in a complete different networks. So prepare this configuration. I'll just create one notepad. then we can copy paste it. So on the PC1, PC1 to this device, let's name it as RPC1 or something like that. So we come to know that it's closer enough to PC1. This is RPC4. Okay. And we can, yes, definitely remove this as well. Now we will not think about keeping all subnets or all those things. Our intention is to read on the routing protocol. Okay, let me call this as RPC3 and also connect a cable. Okay, and one final cable between this to this. Power on all of this. There is option to power on. Now let's prepare the config. PC1 to R PC1. So that's gig 0/0 here. So I'll call it as interface gig 0/0. Interface gig 0/0. Let's say the IP address I would like to configure here is 192.168 1.10.255.255.255.0. I'll keep class 24 for the simplicity. We are not going to calculate the blocks now. No shutdown. Then I go to interface gig 0/1. I say IP address 192. Okay, 1 second. So for the second interface, that is gig 0/1 to so and so, I'll take it in a different network. I'll take 20 dot something, but I'll still keep class C itself because we don't want to spend time on subnetting. How many interface we have? And we have one more, that is gig 0/2. So what I will do is 0/2, which is nothing but, let's keep 10 series only. That is 10 and that is 11. Okay. So PC1, PC2 belongs to 10.10, 10.11, and the gig 0/1 is 20 dot something with this router. Okay. What router is that? That is nothing but between RPC1 to router 1 connectivity. So here gig 0/1. So 0/1 is put up here. So on the router 1, which is nothing but gig 0/0, I will dedicate this as 11. Okay, 20 series, 20.10, 20.11 class C series. This also has some more interface. So let's assume that gig 0/1, we take it on a different network, 30 dot series. So to remember, always the third octet you manipulate. Okay. So let's say this is RPC1. So why don't we keep it 1? So we remember where that 1 was coming. Whatever is intermediate, let's say we give it as 1, 1. Okay, 1, 1. Same thing goes here, 1, 1. And gig 0/0, it's connecting to 4. So might be we can give it something like 4. Okay, that means it's going that side. 192.168, 4.11, 255, so something like that. And then we have one more connected to the downwards, which is PC3. And the interface is 2. Let's put this as 3. Okay, so on this device, on the router device, we have all IP on dot 11, dot 11, dot 11, but with subnet thing. So this is towards that first floor, fourth floor, and third floor. Now you go to RPC4, RPC4 gig 0/1, which needs to be in this subnet. So let's say this is 12. It has another interface, which is gig 0/0, which is connected to the backend. Okay. So that I will put it as might be something like 1 of 1.4, 192.168, 1 dot so and so with that. Okay. Then I'll go to the PC and I'll configure it. Similar way, RPC3. So RPC3, the interface is gig 0/0. What did we give on that? We gave it as a 3.11. So we can give it as 3.12. 3.12. And it has a backend interface, which is 0/1. And we can give it as 1.13 or something. Okay. So 12, 12, 12, 12, 11, 11. So it's easy for anyone to remember and also easy to troubleshoot. So how do we put the config? Let me open this. Let me see if it has something by itself. Okay, good thing is it don't have it. I'll start placing the config. So I'll take this, the first device, which is RPC1. I'll also keep the host name. Host name is RPC1. And then I take this up and I have to do some settings to copy those. Paste. Okay. Copy. Oops, what happened? Actually, I have to bring this config from my base machine. No, I don't see them. Okay, can I copy directly to this? I don't think so. I should have prepared it within this terminal. Yeah, that's a bad luck. I should have created some terminal within this inside the lab environment. So we have some text editor. We could have created this, but now it's too late. We already created on the base machine and I'm unable to copy it. Let me see if I bring it somehow. Okay, I'll do one thing. I'll put it on the Dropbox or Google Drive, and then I bring it to this. Okay, now what I'll do is I have to copy the first config, place within this. All right. So is there any config within this show IP in brief? Okay. See, this is a wrong config. Okay, I cannot keep two same networks. We should have kept one switch and then added it, or we can just take it out one for now. So let me see the config once. Show IP int brief. Okay, this is fine. I'll just say write mem. Then let's apply the router one config. So this is router 1. Okay. Right, mem. What else we have? We have RPC4. Conf T. Hostname RPC4 and write mem. And then one final device we have, that is RPC3. This is the one. Hostname RPC3. Copy paste whatever you prepared and save it. Now, if you try to ping one to other device, they will not ping because now they are in a different networks. So let's see till what extent I can reach it. So if I try to ping my own gateway 192.168.1 dot what gateway have kept on RPC1 1.10. See, my gateway is pingable, but can I ping 11.10, which is another gateway? That will not work. Neither I can reach to another PC or something. So let me check what details it's available. Okay. I think we are now configuring another IP in that range. PC4, RPC4, show IP int brief. This is the range 1.4. So I can say IP 192.168.1.4. Let's keep the PC on 1 or something, class C IP, and the gateway is that router interface. Save this, then you can initiate the ping to its own gateway. So the gateway to the end devices are working, but not the other way. So first what I will do is I will show you the static route concept. So the static route, in the sense, you have to manually tell the routers how to reach the end device. So in case you want to reach the end device here, this should pass it to the router. Router must know that it should go to this. This router should know it should go to this, and then it will be delivered. The request will be delivered. Then the same process, return process, that should send the traffic to the RPC4, RPC to this, and this to this. So I'll go first with the static routing. For RPC1 to reach that destination, R01 is the gateway, right? So my command line on RPC1 should be something like this. First, you take your host IP that you want host IP, you can advertise that, or if you want the complete subnet 14.0/24, then you do that. Because what happens is, in future, if you start adding more number of users in the backend, see, if you have more number of users, so they all will cover in the /24. Otherwise, if you do only one advertisement now, if there is another user, then you have to advertise second time, then third time. Then so better advertise the whole network itself. I'll go to PC RPC4. I'll go to conf t IP route question mark. It will ask me where do I need to reach and what static route I'm trying to add. So my destination is that PC4. So PC4, let's see what's the IP on the PC4. So that is 14.1 on class C. So I can set that. As I told you, I will set the complete network 192.168. 1 second. 14 14.0 question mark. When you do question mark, always remember whether they ask you to put the mask or wildcard mask. If they ask for prefix mask, then it is this option. If they ask the wildcard mask, then you should subtract it with 255 and add this 0.0.0255 for class C I'm talking about. So right now it is subnet mask. So I will put this. Okay. So then
This
it will
vary depends on vendor, right? From
yes,
Cisco to other.
vendor and some operating system will ask for wildcard or subnet mask.
Oh, okay.
All right. Then this router needs to know how to reach that destination. Okay. So for RPC1, either you can say that anything going out of this interface is fine, or you can also define this particular IP of router 1, which will act as a gateway to reach the destination. See, right now I'm here. If I say that I have to reach to this is the path. So I can say, consider this as the exit path or consider this as a exit path because there are no other interfaces. There are certain chances when you have to give. For example, let's say there was a switch here and behind a switch there was a router. So in this case, if you give this, it will not be very good. You have to better give the IP in that case if you wanted to go on this wire to reach this. Since right now we don't have any such terms, I can go with this or I can define the IP. So whatever is my option, I can prefer going with this. So I will say RPC1 will take the gig 0/1 to reach there. Question mark. You can do some more advanced things now. That like let's say you can tag the cost. You can say that to go via this take 10 cost. That is about path manipulation. So let's not get that as of now. Let's only add a static route. So my static route is added to reach that particular destination 14.0 via gig 0/1. Now once I do that, will router 1 know this network? We need to check that. So you take this, go to router 1. The best option that you can do is make use of show IP route command. Show IP route and paste this. Does it know to reach 14? No, it doesn't know. Now you have to apply one more routing table. You have to apply the static routing because we are discussing static routing. So for this, what I will do, same set of commands, IP route 192. What's the IP? 192.168.14.0 to reach the entire network. Now, who is my next hop? Guys, tell me. For this person to send to this, who is the next hop here?
RPC4.
Yeah, this I can take this or I can take my own exit interface. Okay. So I can say if it is a IP, if I need to define IP, then I need to see what that RPC4 is being configured. So it is configured with this. So I can copy this and I can paste it here. 4.12. Okay. Now it will reach till RPC4. Now see how the troubleshooting is done is you need to check step by step. So if you go to RPC1, the very first router where you originated the packet, you will see IP route to 192.168.14.1, right? That PC is 14.1, right? 14.1. Does it know the path? See, now it will show you something. It will say that there is a static routing added, which will take to gig 0/1 directly connected via this. Now you might be interested to see what is the description of it. So you can check gig 0/1 and fetch the report. If there is any description added, you can read it. If no, you have the IP address of that. Okay, of the gig 0/1 10 dot so and so. You can also do the CDP if it supports CDP and what interface gig 0/1. Okay, this is a layer 3 device, so CDP will not work because CDP works on a layer 2 interface, not on the layer 2 devices. So how do you get to know who is the next devices? So you can do trace route. You can also do ARP entry resolution, show IP ARP you do. So when you do IP ARP, you can see 10 dot 11.10, which is connected on gig 0/1. Correct. So these are certain things which you can do, and you need to get to the next router because you know that from the this configuration it is going out via 0/1, and 0/1 only one device you have, that is this router, which is nothing but this. So you do the same step. You do show IP route and you want to check 192.168.14.1, how to reach that. Now it will say that you have a static route in place and 14.12 is the next hop, because in this I added the IP of the next hop, whereas in this I had added my own outgoing interface. Okay, that is why a bit slight 2% of change that you see between this block and this block. In this you will see connected via, in this you will see the next person's IP. Now it is 4.12. Now, who is 4.12? You can try to do ARP resolution. 4.12, it is going out from gig 0/1. So if you see your network diagram, 0/1 is taking to RPC4. So from RPC4, do you have the reachability? Yes, definitely you have it because that is directly connected, right? So if you take show IP route 192.168.14.1, this is a directly connected. See, now it's a directly connected status you see. Whereas in the previous things, it was said as static for us. So now we have one way to reach it. So will I get the response? I'm still not sure because ping consists of two packets, request and response. Until you get the response, your ping will not resolve as a successful result. So let's say if I try to ping this 14.1, it might be sending the packet. For that, actually, I need the help of Wireshark. If I would have kept the Wireshark, I can show you the one way of the packet is going, but the return doesn't know. What does return mean? PC4 knows where PC1 is connected? May not be, because PC1 know now how to reach PC4, but PC4 doesn't know that. The backward route is missing. So how do you verify that is open ARP. Now you do from the other order. You go to RPC4. Who is your PC1? What is his IP? Let's take it this. So he's 1.6. We can do that. We can check that. Does this know it? Let me paste it. 1.26, right? 1.26. See, there is no network in the table. So there is no return path. What you need to do, you need to add the routing, static routing from the other side now, starting from other side. So you will say to reach the response traffic, that is 192.168.1.0/ let's advertise the complete network. What is the path to reach that? If you stand here on PC1, and if you want to reach PC4 to PC1, you are on this router. So you are saying that to reach that 1.1, the next hop can be 0/1 or the IP address of this, either way. So let's say gig 0/1 is the way. Now, same thing you will check from the router 1, that is the next device. You will check, do you have the visibility to that end device, 192.168.1.12, right? It was, what's the IP here? 26, sorry, 26. No, it don't have it. So you will go to show IP route 192.168.1.0, 255.255.255.0. How do you want to reach that? There is only gig 0/0. So let's say gig 0/0. Now you are on RPC1. RPC1 definitely should need to know that because it's directly connected. So if you do show IP route and 1.26, it should say I am directly connected to it. Now I will try to make a ping request from PC1 to PC4 because now we have made a point to keep a to and fro communication. So where is PC4? PC4 is 14.1. So let's ping that 192.168.14.1. Okay, see now what is happening. It says that 14.1 is not reachable. So what could be the reason? Do RPC1 is aware of that? We can give it a try. So if I ping 192.168.14.1. So it's trying to send the packet. Might be it's failing at certain point. If the gateways are not properly defined, we can do a trace route as well to see till what extent it is going. So let's do a trace route. Trace route to 192.168.14. Oh, sorry. The IP was .1. Okay. Oh, yeah. I was trying the good thing. Okay. So see, it when I try to ping 14.1, it went to 11.11, which I guess is this network. Let's see, show IP int brief. Yeah, 11.11. But from there onwards, it's unable to reach there. So let's see if it has a block. Yeah, it has a block. It says that 4.12 is the person. So 14.1, it will go via 4.11. 4.11 is RPC4. Show IP int brief. 4.12, yes, yeah, RPC4. And from there, you definitely have this. So if you do show IP route, you can reach there 168.14.1 directly connected. Okay, so what is happening? Where is this getting dropped then? Control Alt CX. There is one more things that you can check. When you do a ping, try to ping it from the source where you are initiating it. So this is RPC1. So you can say you're pinging it from gig 0/1 because then it will start taking that header itself as a source header. 14.1 source gig 0/. See, no response. Let's see if I can add the source here 0/1. It went to 11.11. And from 11.11, it is unable to reach that. See, this is 11.11. If I try to ping 192.168.14.1 source of gig 0/0, okay, ping 192.168.14.1. See, from here it is reachable. 192.168.14.1, it's reachable. If I give a source of gig 0/0, let me ping this trace route ping 14.1. See, from here it is reachable 14.1. What about from that center router 1? Am I able to ping PC1, the return part, which is 1.26? See, it is not reachable. So one or the other thing would have been missed as of now. Might be the gateway is not configured. Yeah, see here. Actually, I see the subnet is also a different subnet. That is why. So let me make it a /24 1.26 255.255.255.0. And what is the gateway I configure? It should be 25. No, it is. See, it's because our PCs are not properly configured. We cloned the project, so some of the blocks were retained. So let's say this is 192.168.1.100. So make sure always your configurations are good. If configuration is not good, then definitely it's not gonna work. See, now you can reach 14.1, right? So earlier, the 14.1, which you were not able to, now you are able to. And if you try to see the trace, 192.168.14.1, enter. See, now the different routers. So this is interesting thing. You need to know how the packets are traveling. So when you are originating the connection from PC1, it went to 1.10. So what is 1.10? Its own gateway, this one. Then it went, see, it went to this. That is 1.10. Then it went to 11.11, which was nothing but this. So it said, I'm going this way. Then it went to 4.2. 4.2 was this interface. Okay. And then finally it reached the destination, which was 14.1. This is 4.2. This is 11.11. And this is 1.10. So now ping is happening like this. But what method are we using? We are using a static method. And you see how much time it took us to configure the static routing. And even in the production, even in your networking job, while you add the static route, it's a time consuming process. You need to see how the destination goes. You need to figure it out, and then you will define it. So that is why in the production, when there are multiple routes required, if it is the one route or at least a 2 or 3 route or 5 route, it is okay. We can add static route in each one of them. But if you want to add hundreds of route, you have thousands of users, then this is not a practical scenario. You have to get into OSPF or EIGRP for that. So either one is good to go with this. Let me try to ping on the other side, that is PC4 to PC1. They should have a to and fro communication. So when I ping PC 192.168.1.26, see, there is a reachability. And if you try to put the trace command, you will see which way this is traveling. So now you initiated from this guy, PC4. So it is hitting 14.12. This is 14.12. 14.12 is sending it to this, which is 4.11. Then that goes to 11.10. And then finally it reached this guy called 1.26. 1.26. So how many path it saw? It saw the path 1, path 2, path 3, and finally the destination. So we call it as 4 hops now. Okay. From source to destination, it went via 4 hops. So that is what is seen here. 1, 2, 3, and 4. Okay. So that
So one doubt
yeah.
from router 01, if we give the destination gateway, I mean destination IP of PC1, and then the gateway as gigabit 0 by 0,
Okay.
is that is possible? I mean the RPC1 interface I can give as gateway.
You can give anything from R1, from the router 1 point of view. You can
Hmm.
give its own interface, or you can give the RPC one's gig 0/1.
Then one hop will be less, right? In that case.
No, no, no. I mean, see, it is just the way you configure the static route. But in any way, the hops are not getting considered. See here, if you see here, from this router to go to this side, I configured the IP of the interface. But
Hmm.
while I was going this side, I took the interface of that
Okay.
1.0, right? Yeah, I consider, sorry, this should have been this one. See.
Yeah.
So in any way, hops will not decrease. It is just that you're telling this router how to go outside. It's a next gateway, what we call.
Okay.
If you declare your own interface, then it itself is acting as a next hop gateway. If you're
Yes.
declaring this, then this is acting as a next hop gateway.
Okay. Okay. I got it.
Okay, now I want to give some homework because I want you guys to practice. Since you have all, I'll give you this command line, don't worry. So the assignment is, or the project is, communicate between PC1 to PC3. You can go with any RFC 1918 private IP range. This is one assignment. And how do you test it? Test it via ping and trace route. So you should have the successful result. So this is something which you need to do it, and you are free to take any IP range. Don't need to just change this and do that. And also remember the complication that you faced while you cloned it. Remember, there are certain things which will retain the configuration, like PC retain the configuration, whereas all the PCs, all the routers, the configuration was flushed out. So the PC, we had some block in the PC1. That is why the initial ping was not happening. Otherwise, it was smooth as butter. If that PC1 we would have taken care. Anyway, we get to know when we lab it, right? So you just lab it and get this assignment sorted out. You can just share the ping and the trace route in the group so that even others know that what is the assignment and they can fix it. So this was the problem when we go with static. I will show you in the next class how a dynamic routing protocol would have been a much, much, much better option and why the enterprise prefer going with them.
I have one doubt. This one, if the PC has a Wi-Fi connected,
Okay.
so if I send a packet in static route, this will affect the route, right?
It will
The
not.
PC will take which route first?
See, I'll tell you what will happen. So, for example, instead of this cable connection with the router, you have a bit different connection. Like you have a switch here, and this would have connected to switch, and internally switch should have been connected to the Wi-Fi modem. So, using the wireless concept, the laptop would have been fetched the IP and so on from the modem itself. Now, modem is connected to switch. Okay, and let's say this cable is not required because we are having the wireless connectivity, and the switch should be connected to this. So it is again the same concept only. You receive an IP 192.168.1.26, which is behind this gateway. So the routing is still gonna be the same only. It's
But
just that
the gateway it will take is the for the Wi-Fi, right? Or it,
no, that is a wrong concept.
okay.
Router is just a broadcast mechanism. Router is not a gateway now. Router
Mm-hmm.
itself will be pointing all the gateway to this interface. Okay, because here you are configuring only DHCP services. Yes,
Okay.
yes, there is again a clause. If this modem you were acting as a router, like if
Mm.
this modem would have been kept here, which is connecting with the service provider, then in that case, yes, the modem would have been acting a different person now. But in your scenario, it is just to enable the DHCP service. So DHCP service in the sense, whatever IP block that you dedicated, like /24. So that service you will enable in the Wi-Fi modem, which via the wireless will receive on this person. So he might have received any IP from this range, 1./24, which is nothing but ultimately this interface only.
Okay.
Okay. Modem is
Yeah.
just used for the LAN service in the scenario, in this scenario. Not
Yeah.
it is that it is acting as a different gateway.
Okay. Okay. Something like if I connect a printer directly.
Yes, let's say you had a printer. This was a switch was connected to this interface, and switch is connected to Wi-Fi modem and the Xerox machine or the printer. So all these devices ultimately are behind this gateway only. So they will have their IP, the mask, and the gateway. You will see that pointing to this. Same goes with the Wi-Fi case. Wi-Fi will have some configuration to be configured. I will say that I'm making use of antenna 2.5. And in that antenna, I will create a SSID. I will say network journey users. And that SSID, when it is broadcasting, the users will connect to that. And once the IP is received, that's basically from this gateway only. This is the only gateway which is going to create it. You should not create any new gateway within the router. There are options to create a complete new network also, because this modem can be treated as a LAN device or as a device which is connecting to outside internet also. So if you are connecting this as a LAN service, same DHCP you make a pool here, and one of the IP from that will be received to the users.
Okay. It's clear. Yes.
Okay.
So, while pinging PC1 to PC4, can't I just choose the gig 0/0 in every router?
It depends on the cabling. So if, for example, if this is PC1 and this is PC4, on some router you have this, and in this side the cabling is on a different interface. That is your question, or I took
Yeah,
it?
yeah, yeah, sir. Yes, 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 sir.
Yeah, it is about your cabling. While you put the cables, try to put in a gig 0/0, but that is not possible, right? You might have used in a different path, and then that is not available in the second path. So you can do some changes to have that. See, for example, here, this is still here, it's okay. Yeah, you could have changed it. This, if I would have cabled between this and this, I would have cabled between this, then all would have been 0/0, 0/0.
So, sir, like while configuring the or making an topology, sir, we have to think between the like we have to think about the cable also. Like there is a same Giga Ethernet cables interface.
Uh, I didn't understand. Come again.
So I want to say that like while like here, I guess you didn't think about the cabling. You just
Uh-huh.
so sir like while making another topology, like we have to think about cable, or we'll just like do it just cabling this.
See, in production, it is not feasible. Have you seen any time production data center? How many times would you see which port to port you can cable it. It is not feasible. See, I'll show you some data centers. There will be so many cables piled up. It is not just few cables that we connect. So you cannot always keep a track that this should go to this should go. Sometimes it's about free port also. See, for example, this one. Now you cannot always think that I have to reserve 0/0 because on the other side it is 0/0. Whatever free you get, you just cable it and put inside a inventory management, or keep the description. That is why the description is helpful in such scenario. And the description you can mention it is uplink to switch 1, or it is downlink to PC 1, like that. Okay, because
Will also give labels to the
yes, you
cable,
can
right?
keep the label also on these wires. If you see closely, there are a small piece of label which says that from R01 gig 0/0 taking to switch 01 gig 1/2. So that interface to interface is only possible in the lab environment. You can have very limited number, so you can do it, but not in the production. So we see description. If you are a data center technician or engineer, you have the access, physical access. You need to actually go to the rack, see, trace the cable. You have to trace the cable from this to which device it is getting connected. That is how people do in the real data center. They keep tracing the connection, the cables.
Okay.
If you see this, so many interfaces. If you see this, see, there are a lot of interfaces. This is how the production will look like. Okay. You will see always bundled with so many cable. This is just a lab environment. So our choice of keeping in a systematic manner.
So, sir, we can like make a choice of selecting the gig Ethernet to route the packets.
Sorry, sir, come again. Your voice is a bit low. Come again.
So, sir, we can just configure or make a choose of our choice, like while taking the gig Ethernet, like to configure to pinging PC1 to PC4, and we have our own choice to exit the gateway, like 00 gig 0/1 or gig 0/0.
It depends on how it is cabled. See, for example, if this was a 0/3, or this was 0/4 or something. Okay. So in that order, you will prepare your IP route connection, the static route connection. So whatever you have on your topology, depending on that, you can create. Either you can create, you can put the self interface itself, or you can put the next person's IP address. Okay, you should be ready with whatever outcomes it could be. You should know the fundamentals, and the other rest of the things are not necessarily required that it's always 0/0 or 0/2, or they could be always 0/0 on all the sides. It's not necessary that to have that pattern.
When we connect from our router to the external WAN, the speed of the communication or the data flow, it is determined by the router, right? If it is in dynamic.
It depends on multiple factors. Let's say, for example, the interface that you have is a gig, and the interface you have is a gig. But if you're making use of the cable of a lower capacity, like Cat5 or lower capacity, so in
Yeah.
that case, you may not be able to match up with the interface things. That could be in other way also. Let's say you are having a lower interface, because you might know that some device has the Ethernet interface, but then you are using the best cable, Cat6 cable. Now, this also will not be sufficient enough. So best practice is your interface speed matters of a router, your cable matters. Okay, so this matters. And also when I say interface, there is something called a SFP modules. Okay, these modules are plugged into the devices. So that speed also matters. So let me show you here, SFP module. These are basically converters. Let's say on
Yeah.
your on your router, you don't have a optic fiber option. You have only RJ45, but your service provider is giving you optic fiber. So you can use this kind of converters. So if you search for like SFP module, optic fiber to RJ45 converter. Now this speed will matter as well.
But if one is a 10 gig speed SFP and another one is 1 gig SFP, it will not work, right? And
No,
the
it will
SFP in
work.
both end.
It will work. The bandwidth will be of that shortest or the smallest one. Whatever is the
Okay, that was the
smallest
question.
one,
Yeah,
it will consider that.
yeah. So the router will decide that. I mean, because there is no other option.
Yes, yes. Let's say if the cable is a weak cable, then it basically can only send whatever this cable can accumulate. Let's say 100 Mbps, then only 100 Mbps will be sent by the routers.
Got it.
That is why you keep those duplex and speed all in auto mode, right?
Auto mode, yes, yeah.
You don't set 1000 or 100 or something.
Clear, clear.
Yes.
I have one more doubt.
Yes.
Is this CDP neighbor and LLDP neighbor is same? The
Yes.
commands?
Yes. So CDP is a Cisco Discovery Protocol, whereas LLDP is a open source.
Okay.
So by
But
default, these runs on a Cisco, this one, but not this one. If you disable CDP, then LLDP come into picture.
Okay.
Okay. So any doubt, guys? All right, guys. Yeah, homework is with you. I want you to work on this PC1 to PC3. Okay. Put the static route, try to make a different combination, next person's IP or your own interface. If you want, remove the cable, make use of a different interface. Try all the trials and try to test by pinging and making a trace route. Okay. All right. So
Sure.
we
Yeah.
connect tomorrow. Have a nice day, guys. Take care.
Thank you.
Thank you,
Thank
sir.
you.
You
Thank
too,
you so
sir.
much.